Hey everyone, welcome back to the new video and hope you all are doing well. And as I said, I'm gonna be a little bit more consistent these days, so here's the new video, and today we are gonna be talking about MCP servers and how they can be hacked. Just like every other technology, MCP can be hacked as well. So before we jump into that practical thing, like how you can look for MCP bugs and everything, we're gonna talk about what MCPs are in the first place, okay? Okay, so to help you understand MCPs and how they work, I have created a diagram, so let me show you that. So here we are, and just a little diagram so you can understand the flow. Okay, first we have is user sends a prompt. That is you, the user who wants to do something. Let's take an example. Let's say you want to fetch all the events from your calendar for tomorrow. Just a simple task. So you send the prompt to LLM, get my all events for tomorrow. That's all. Obviously, you give it in a natural language. And now we have the step AI model, agent, LLM. It could be any AI model like ChatGPT, Gemini, Claude. There are so many in the market, could be anything. So the AI model takes your query and then it sends it to the MCP server tool gateway. MCP sits here and MCP has access to different tools. It also has access to your calendar and it fetches your calendar details through making API calls. But before it does that, obviously it has to be authorized. So you are the one who actually authorized the MCP so that it can access your calendar. You have already done that. It already have access to it. That's why we have three points here as well. Auth layer that has API keys if you want to provide API keys, policy check permissions, basically what kind of permissions the MCP have, what are the limited permissions, or what are the things that MCP cannot access and can access. Everything comes under this policy check permissions. And then we have audit logs monitoring. So it's basically simple. Whatever MCP is doing, making API calls, fetching queries, and whatever tool it's talking to, whatever third-party tools or service it's talking to, this keeps the logs of everything it's doing. So yeah, checking API keys, have permissions or not, keeping logs and everything for security purposes. So when it's done all that, it goes to the tool router. Basically, tool router have access to, as I said, MCP have access to multiple tools, but how the MCP is going to decide which tool to use, that's what tool router does. In this case, I have provided few tools that this MCP have access to, like database queries, if you want to make changes with the database or fetch anything from the database, and file system access to write something to the file or to fetch something from a file hosted on a cloud or something, or external APIs, making calls to external APIs, or internal company app. Let's say there is an internal application that you want to access and only you can access that, obviously. That's why we have these steps, checking permissions and everything. So yeah, MCP can do all that based on the configuration. But in our case, we took the example of calendar. So let's say there is another tool here and let's call it calendar. Now it could be calendar like Google Calendar, and you want to fetch all the events from your Google Calendar and you have already authorized the MCP to use your Google Calendar. So once it makes the API calls to Google Calendar, just a normal API call like the HTTP request, it would be a GET request because obviously we are fetching something. The API will give a JSON response, because that's how APIs work, right? We send something in JSON, we get a response in JSON, but this JSON response is converted to a natural language. The LLM doesn't give us the JSON response. It simply converts it into natural language. Okay, here you go. You have like 3 events tomorrow, maybe a birthday party, a meeting with someone, I don't know, whatever, but it will give it to you in a natural language. So yeah, that's what the LLM does. It make use of the MCP to access tools and services. Tools and services usually respond in JSON format or in code format, I don't know, anything, and then it gives a response to you in a natural language. So that's how it works. Nothing complicated at all. Hopefully this diagram is making much more sense now. So yeah, that's how LLMs work. Now we're gonna talk about OAuth. Why I'm mentioning OAuth? Because LLM use OAuth for authorization purpose. When I said you give permission to MCP to access your Google Calendar. But how you do that? You do that using OAuth. You give it access, you approve it, and then the MCP is able to use it. And obviously, we know that there could be multiple bugs in OAuth. We know there could be bugs in the redirect URI, state parameter, scenarios where you can steal the code and exchange it for access token, and that can lead to account takeover. So there are a lot of different scenarios, and that's where the bug lies. So it might be sounding a little confusing right now, but I'm going to break it down step by step, so don't worry about it. Now let's move to the next part of this video. Okay, so now that we talked about what MCP servers are, how they work and everything, let's talk about how it can get hacked as well. So I'm going to be sharing you this blog by Sigsec. He's an amazing guy and he shared this blog, and I think this is really cool and I wanted to share it with you all. So this is actually account takeover by exploiting MCP OAuth servers. We know that MCP uses OAuth for authorization, you know, OAuth 2.0, but this can be hacked, and this is what we're gonna look into. So over here we have the basic overview of what MCP servers are and everything, but another very major point about this is Open Dynamic Client Registration. You have to understand this first before understanding this bug, because this is really important part of it. So we know that OAuth is a feature that helps us log in into a web application without sharing the credentials, right? You can just click on the feature to log in with Google or log in with GitHub, and you can just grant access, and then you will be able to log in any application that is providing that feature. So this is what us as a user see things, but what happens behind the scene is how developers actually implement OAuth. To cite an example, I want to show you this Google OAuth. Basically, when you see that feature, login with Google, what happened behind the scene? This is what happened behind the scene. These are the steps. So basically, the developer, when the developer wants to implement that feature, he has to register the client. What do I mean by client? Client means the application, their application. Let's say I have my application and the name is Medusa, okay? And I want that application to have a login with Google feature. To do that, I have to go to Google OAuth provider, which is Google Cloud Console. So if I open this up, I will see, as you can see, the URL here, cloud console cloud.google.com. Okay, so I'll go here. Why it's taking so much time to load. And then I'll see, okay, so this is how it looks like, and you have to, obviously this is paid, you have to create an account and everything. So over here you have to create a project. As you can see, there's an option to select a project. If I click on project, I don't have any projects yet, so I'm gonna click on new project, and over here I'll get the option to type project name and everything, so I'm gonna leave it as default and click on create. Okay, as you can see, it is creating my project and it's created. Okay, let's click on select project. I'm doing all this to help you understand something. Okay, you will get it why. Cool, so my project is here. Now let's go back to this page, and over here we can see it says create Google Cloud project. We already did that. Navigate to the Google Cloud Console project creation page and fill in the required fields. We've done that already. Enable Google People. Wait, what? Enable Google People API. Navigate to API and services and find Google People API. Okay. Fill in the app and name. Okay, cool. Let's do it, guys. Let's do it. Okay, so I gotta enable this. And now I have the page that I want to see. Okay, over here you can see OAuth consent screen. Let me increase the size. So I'm gonna go to this and I'm gonna click on get started. So over here, this is how I configure my client for implementing the OAuth feature. So let's say the name of the app is Medusa and user support email. So I'm just gonna give in my email. I'm gonna click on next. Let's say external, next. Okay, finish and create. So As you can see how I'm filling these forms and configuring my project, it's gonna process it, and it says OAuth configuration created. So now I have the option to create the OAuth client. This is literally the most important step because this is how you are going to create the client ID and everything. So application type is web application. Let's say it's a web application. Okay, next up we have to add the URI, authorized JavaScript origins. Okay, let's see. HTTP origins that host your web application. Basically, the path for my web application. So in this case, I'm just going to add my website. Cool. So now we have to add authorized redirect URLs. It means when the client click on the consent page to give the permission to the application to use its data, where the application, not the application, where the Google is going to redirect that user to. So it's basically going to redirect the user to back to our application, right? So there is some path for the redirect URL. I'm not going to do that right now. And I'm going to click on create. Was it compulsory? I don't know. But we're just testing it, right? Actually, redirect URL is very important. You're supposed to provide it. But as you can see, once we click on create, we are provided with a client ID. Okay. And if I click on edit button, let's see. My client secret over here is hidden, but obviously I can see it, and it is really important. It shouldn't be public. If you see client secret somewhere in the JavaScript file, report it. Anyway, so this is my client ID and everything else you can see here. Of course, I'm going to delete this after the video. Anyways, so this is a step. This is how I configure my application to use Google OAuth. But obviously there is more to it. Now I have to go back to my code and configure all these things, where the client ID and everything. But I'm not gonna go too much into developer kind of thing because I'm not. Anyways, I just wanted to show you the struggle we went through, okay? Now, what if all of this could be automated? And that's what DCR do. Yeah, I went all through that to explain you. So this is what Open Dynamic Client Registration do. It is basically a feature of OAuth that lets you register a client dynamically. Now, to give you an even better example, I'm reading this blog from Descope. You can find the link from the description of every blog I'm mentioning in this video. Well, okay, so here's a simple example. Imagine you're checking out from a new online store. If you pay with credit card, you have to enter your shipping address, billing details, and card info every time you shop somewhere new. But if you have saved this info before, your browser might offer to autofill your details with single click, even if you have never shopped on that site before, right? Okay, so like autofill feature, but for OAuth. Now, this is essentially what Dynamic Client Registration DCR does in the world of web-based authorization. Just as autofill simplifies sharing a shipping address, DCR automates how applications register with authorization servers. When I say authorization servers, I mean Google, GitHub, or any application that provide these features, you know, these OAuth feature. So they can participate in OAuth and OIDC flows with minimal manual setup. So you can read more about it definitely, but I'm just going to read these 4 steps because this is literally what we just did. I believe in practical stuff more than just reading. That's why I showed you how to do it manually before reading these steps. Anyways, DCR automates the client registration process, letting clients discover authorization servers and their registration endpoints. So the registration endpoint in this case was the cloud. Wait a second. It was console cloud google.com. And it allows clients to submit metadata, example name, redirect URL, which we had to fill manually, if you remember, and then receiving client credentials, client ID, and optionally a client secret, which we received as well, we saw just now, enabling clients to immediately use those credentials in OAuth or Open ID Connect flows. So this is what it does. Now, obviously, there are different kind of services that does these things. You can go more into that, but this much knowledge is enough for you to understand the bug now. Going back to the blog. Okay, so now we understand what DCR is. Let's look at the vulnerability chain. So this is the vulnerable configuration, open DCR endpoint, no authentication required. Arbitrary redirect URI accepted. Isn't this a red flag? Like, you can open the DCR endpoint and there is no freaking authentication in it. It means you can provide any URI, like attacker controlled URI. That is crazy. And there is no allow list. Public clients allowed. Token endpoint method set to none. I'll explain that soon. PKCE not enforced despite being supported. I'll talk about that as well. And authorization page shows generic domain, not app name. You know, the interesting thing about all of this is it's not just that there is one condition for this whole exploit to be successful for this one-click ATO. There were multiple conditions, and these are the conditions actually, and we're going to talk about it one by one. So that's why I'm saying this is freaking great. So here's the attack flow, but I'm not just going to read into it right now. I want to show you the steps first. So first step is to register a malicious OAuth client. So this is the URL. This is the URL of the MCP server where you can register a client. So as you can see, in the post body, we have client name, which could be literally any arbitrary name, and the redirect URI, which is the attacker controlled URI or URL, you can say in this case. And then we have grant types, authorization code, because we want the authorization code, right? For OAuth, we want the authorization code so we can exchange it for access token, and obviously once you get the access token, you're cooked. So if you're still confused about OAuth, I have actually created a pretty detailed video on OAuth, and not just OAuth but multiple other authorization methods that you can check out from the I button. Okay, so response types, obviously code, token, endpoint, auth method set to none. This is actually allowed. That's why he was able to set it to none, because if this wasn't allowed, then this attack wouldn't be possible actually. And I'll tell you what this is very soon. So the server happily responds, client ID, token endpoint auth method, none, redirect URI, which is attacker controlled path, then the client name, which is arbitrary value again. No validation, no question asked. We now have a registered client pointing to our server, and that is crazy. So craft the malicious authorization URL. Whenever you're exploiting OAuth, I don't know if you have done a bit of practicing in OAuth, a lot of people ignore it, but you are supposed to create a malicious authorization URL, and most of the crazy thing happens in the redirect URI parameter, because that's where you exchange your code for an access token. Okay, so this is the malicious authorization URL, which contains the client ID, redirect URI, state, scope, classic. Notice what's missing, code challenge parameter, because PKCE isn't enforced. What's PKCE? PKCE stands for Proof Key for Code Exchange. So in the normal OAuth flow, after you click the approve, the server sends an auth code to the redirect URI. And that code is basically like a voucher, you know, whoever has it can exchange it for real access token. So if an attacker intercepts that code midway, they can steal the token. So this is how actually all the exploits work in OAuth, to be honest. But PKCE prevents it. PKCE makes that stolen code useless. So what happens here is, before starting login, your app generates a random secret and locks it with one-way hash. And it sends the logged version to the server. When the flow completes, it's time to get the token. Your app must also have the original unlocked secret to prove that I'm the person who created this, and the server checks if they match or not. So in simple words, it just uses a random string and a hash form just to check if you are who you say you are, you know, like you're the one who initiated that. So what happened here is the MCP does support it, but it didn't implement it. And that's why this is the another condition that led to the successful ATO. Now, the third step, victim sees a legitimate looking domain, vulnerable MCP, whatever the MCP that was vulnerable. The consent page shows something generic like MCP server or just a domain name, nothing that screams attackers, like a typical phishing page we see. So they click on approve. And what happens? Once they click on approve, obviously the victim gets redirected to this particular path. So this path is the redirect URI value. Remember the redirect URI value we see over here. They get redirected over here, and then we have the authorization code and the state. So now the fifth step is token exchange without authentication. We are saying without authentication is because there is no PKCE enforced. So now this is how our request looks like. We are sending requests to the token path, classic OAuth steps, by the way. If you're not getting it, then you really have to understand OAuth first. I really suggest you again to watch that video first. Anyways, so we have content type, grant type, authorization code, obviously, then the authorization code that we just received when the victim clicked on the approve button, and then redirect URI and client ID. So no client secret, no code vif, just vibes. Okay. So the response now contains our access token. Obviously, it's a bearer type most of the time, and the scope is read write, means we have permission to read write now, and the expiration. Okay, yeah, that's it. That's all it took. Game over. We have persistent access to the victim account. Okay, so now I want to show you something interesting. So over here, we have the hunting methodology, but the thing that we're interested in is this configuration analysis. Okay, so what they did, they focused on the MCP domains like this and looked for path that contains OAuth configuration. So OAuth configuration paths usually look like these. Okay, so doing that, they found out that one of the paths has a weird configuration with multiple red flags. So as you can see, the registration endpoint is public. It shouldn't be public, actually. If it's public, means anyone can go on and register their own client, similar to what the attacker just did in this case, you know, registering their own client. Where did it go? Yeah, over here. So registering their own client. To be honest, they shouldn't be able to do this in the first place. I mean, if anyone can register the client like that, then what's the point of having OAuth, you know? But this was only possible because of this configuration. First of all, the registration endpoint is exposed. Second of all, the token endpoint auth methods supported are client secret basic and another is non. Now this is another red flag. Why? So non means the client doesn't need to prove who it is when asking for a token. Normally, when a client exchanges the auth code for a token, the server asks, "Who are you?" And the client has to present a client secret, basically a password that was assigned during the registration. But non means no password required, just show up with the auth code and the server hands over the token, no questions asked. And this is literally what just happened in the above steps we saw. Now another is Go challenge method supported, which is S256, which is just the name of the hashing algorithm used in PKCE. The full name is actually SHA-256, so we know about it. Red flag is no direct URI validation on registration. So you must be thinking, okay, so many red flags, how is that even possible? This happens because, you know, like a lot of companies are spinning up MCPs, automating everything, and when they're like doing this too fast, things like this does happen. And this is what our job is, you know, to find this kind of stuff. And I'm not going to say that, okay, that was a really lucky finding, not at all. Actually, it was all the research and the enumeration, as you can see, the recon and everything, and that led to one of the configuration that looked like this and allowed ATO. So that is really crazy. So obviously there are some roadblocks as well. Sometimes implementations were smart enough to restrict redirects, like not any redirect is allowed, only a few redirects are allowed, but you can try to bypass it, similar to how you bypass in SSRF, like trying local host variations like these. And yeah, you can definitely read through this. So I think overall this was really amazing bug, and I loved talking about it. And if you come across blogs like these who are like crazy and you want me to talk about it, do share those blogs in my server, in my Discord server. If you haven't joined it, you can check it out from the link in the description, and I would love to explore it in my future videos. Okay, guys, that's it for today. This is really interesting and I just wanted to share with you all as well. Let me know your thoughts in the comments section. Thank you so much for watching, and I'll see you in the next one.